Hello, everybody. My name is Guirigay. I'm the global leader for AWS Solutions, where I focus on solutions for infrastructure. Today, we're going to talk about performance testing and building reliable applications. We don't have that many people, but how many of you are developers? Okay. Infrastructure architect, cloud architect. Okay, perfect. So at some point, somebody will ask you, what's your performance degradation point? How do you know that when you launch this particular product, it's going to stay alive when you get to 5 million users or 10 million users or whatever it is, right? So that's the idea of performance testing. So with that, let me first do a commercial break. AWS Solutions, we are an organization within AWS where we basically build products on top of AWS. What you will see is that many times there are use cases or challenges that maybe a service by itself cannot solve, or you have to put a lot of code together, bring a lot of pieces together, put together a lot of building blocks, and then you can have a solution for that. So our organization does exactly that. We identify the most present, the most common challenges, and then we build solutions for that. We have over 1 million deployments. Everything we build is open source. Everything we build, we put it in a place. I don't know if you can see right here. What is my, there you go, perfect. Right here, aws.amazon.com/solutions. Everything we build, we put it there. Now, one big difference of AWS Solutions and AWS Services is that AWS Solutions are single tenant. What I mean by that is that you deploy it in your environment. When there is an upgrade, you can automate it, you can do it manually, but when there is an upgrade, you have to upgrade that particular solution. And when you no longer need it, you go and remove it. Versus AWS services, which are SaaS, managed, and updated by the organization. We have quite a few hundred of solutions out there, but for example, who's using CloudFront today? Okay, so if you're using CloudFront, probably one challenge you have is image optimization. We have a solution for that. We have a solution that in real time, you can optimize, transform, apply content moderation to images and stuff like that. If you are thinking about, hey, what happens if I go from x86 to Graviton? We have a solution for that. The Cloud Intelligence Dashboard, one of the many dashboards included in that particular solution is the Graviton Savings Dashboard. So I'm not going to sell you on each one of them. Please go to the solutions library, take a look. You will be surprised how many really cool solutions ready to be used, ready to be deployed, nothing to develop, are available. Okay, now let's get into the actual topic. Resiliency versus reliability. One big misconception from customers is that resiliency is everything. So let me clarify. Resiliency is when something happens, how do I recover from that? Reliability is everything I can do to prevent from that happening, okay? So performance testing falls under the umbrella of reliability because it's all about understanding your environment enough to make sure that you don't have to worry about resiliency. Now, that being said, you should always worry about resiliency because you just never know what could happen. But you want to minimize risk. Risk mitigation is one of the things you do with performance testing. Now, what is performance testing? Performance testing, the simple definition is understanding how your environment, application, infrastructure, whatever it is, behave under different conditions, okay? Those conditions could be load, like this guy, I'm gonna call this guy Peter, right? Just because my friend Peter is sitting right there. So, could be load, like, yeah, he's holding an elephant. That elephant is probably 2,000 pounds. But another condition would be for how long, right? So can he hold the elephant for a minute, for an hour, for 3 days? The other condition would be, can he walk with the elephant on his back? Again, if you start applying all these conditions, that's where you get into like the types of performance tests you can apply. And let me start with that. First one, load testing. Emphasis on the word expected. If you have an application and you are always expecting, let's say, 1 million customers, you should always be prepared for 1 million customers. Let's say 1.2 million, 800K, kind of 20% buffer, right? So that's the expected load. So that's a regular traditional load test. Next one is stress. Okay, so my expected load is 1 million customers. At what point will my solution break? Or at what point my user will start experiencing some type of degradation? This is where you apply a stress test. Now, a stress test changes from company to company. For me, could be 5 million. That's the max point I want to get to. For you, might be 10 million. For you, might be 200 million. It doesn't matter. The point is that, especially if you have a complex environment where you have first-party API, third-party APIs and components from other teams and stuff like that, every single component might have a completely different performance degradation point from the other. And you will never know that unless you do this. Okay, next one, endurance testing. This is pretty cool. It's also called soak testing. This is all about the endurance. Remember when I told you about Peter holding the elephant? Maybe for a minute. He can hold it maybe for 2 hours, maybe for 4 hours. So that's the point of endurance testing. When you have solutions like, for example, using Java, memory leaks will not show up after 5 minutes. They will probably show up after hours of runtime. Timeouts, connection issues, whatever it is, right? They always show up after an extended period of time. So that's why you always want to do that. Spike, this is a pretty cool one because most people focus on the way up, meaning that, hey, I want to know what happened when I go from 0 to 5 million. But two important questions. What happened when you go from 0 to 5 million in 1 minute? Think about this. The next phone, whatever it is going to come online. You can only buy it on Friday at 9 a.m. What do you think will happen at 8:55? Hey, maybe nobody's connected. At 8:59, boom, now you have 5 million people trying to buy that thing. Now, 9:55, no longer in stock. What do you think is going to happen? You're going to go from 5 million down to 0. So this is why it's called spike testing. You want to measure the ability for your system to handle those sudden spikes on the way up or on the way down. For example, can I autoscale fast enough? You are using Kubernetes, autoscaling groups, whatever it is. You need to use spike testing to understand how fast can you upscale, but also how fast can you downscale. So why pay for something that you no longer need? And the last two, I'm going to go really quick. Scalability and volume. Scalability is very similar to spike, but it only focuses on the way up and also over an extended period of time, like more like a realistic situation where like, hey, I'm going to go from 0 to 5 million maybe over 3 hours. And the last one, based on the documentation you are reading, based on the speaker or the presenting you are listening to, they might say volume is the same as stress. I like to keep them separate because volume to me is about data. Data ingestion into a database, data extraction, file uploads, things like that. Now, these are the 6 different types of tests. It's not one or the other. You can actually combine them. And each particular test will completely give you different insights. Okay, like for example, yes, I can support 1 million. Now let me find my performance degradation point. Oh, great. Let me see for how long can I stay here. Oh, great. Let me see if my containers are autoscaling fast enough. Oh, this is all cool. Let me see if my database can handle all this kind of data. All of that you can get by doing all these different tests. Okay, when you should be doing a test. I actually stole this quote from a presentation earlier today. Early, often, and after. If you look at my flywheel, and this is the joke I usually use. If you are in IT and you are a developer or a cloud architect and you are responsible for something and you are breathing, you should always be doing performance testing. I used to be the CTO for a bank many, many years ago, and the government would pay to all the retirees their pension this particular month, right? In this particular week of the month. We used to go to the bank. This is like in the early 2000s. AS400, anybody remember that? We would go there on a Saturday night and do performance testing on all the systems to make sure that particular week our system was going to be able to support the load, because it's people putting money in and people getting money out. So infrastructure changes, code changes on a weekly basis, you decided that you should always be doing performance testing. I'm gonna skip the benefits because I want to do a quick demo, but you can kind of get it, right? So user experience, look, if you have a solution that takes 5 seconds to show the font you wanna buy, guess what? You're probably changing providers at that point, right? Because it's too slow, you're gonna get it from somebody else. User experience and reliability, we talk about it. Cost optimization, let me actually highlight this one pretty quick. Let's say you are sizing this infrastructure. Let's go small, medium, large. Small, you do a test, 2 seconds response time. Okay, good. Let me do medium. Oh, 1.5 seconds. Great. Let me go large. Perfect. 1 second. What you do? You go extra large. Oh, same 1 second. Let me go double extra large. Same 1 second. So at that point, this is all about capacity planning. Why do you need to go bigger if you don't have to? Okay. Now that I hope everybody agrees that doing performance testing is the right thing to do, how you do it? If you are telling me that you are either using load testing from your laptop or from 2-3 servers in your environment, you are not really doing performance testing. Or if you are launching something into production and you are sending an email to your entire company and telling them, oh, at 9:05, go to this page and hit refresh, refresh, refresh. That's not load testing. We at AWS, we have this solution called distributed load testing. It's a solution, remember, 100% open source, no extra licensing, and you pay for what you use. And what I mean by that is there are underlying services behind the solution. There is Lambda, there is ECS Fargate, DynamoDB, all of that, but that's what you pay. Now, one thing I can tell you, the solution is extremely low cost. In the documentation, we actually have like a baseline, a 29 hours test for like 10,000 users running for like 29 hours is like $29, something like that. So it's extremely low cost. The solution applies to small customers, medium customers, large customers. It could be the roofing company in the corner of your street, or it could be a company like SBI Securities, which is the largest online trading company in Japan, that when they migrated from on-prem to the cloud, they use our solution for all the risk mitigation and for all the stress testing. I'm going to skip the roadmap, but I want to go into the demo. Okay, so the solution is available through a CloudFormation template. You download that from our page. Actually, if I go really quick here, I still have 10 minutes, great. So this is the landing page for the solution. You like the solution? Oh, this is great. Let me go and deploy. You go here, launch in the AWS console. This is going to take you to the CloudFormation stack. You hit next, you enter the data, and that's it. Like literally within 5 to 10 minutes, based on the region, it's up and running, ready to be used. And what you get at the end is this application. You will be told what's exactly the URL you have to use. Don't pay too much attention to the user experience in the UI. We are revamping all of that in the next 3 to 6 months. So hopefully by reInvent, there is going to be a brand new user interface on the solution. But let me go and do a test right now. Let's say that I'm going to run this test called Midwest AWS, right? Now, remember when I told you that if you're running a load test out of your laptop, that's not a real test? It's because there are physical bandwidth, CPU limitations, all of that. In this case, I'm going to say that, look, I'm going to do a test out of 50 different tasks or containers. And what this means is that there will be 50 different IP addresses or containers, each one generating, let's say, 200 users, right? Perfect. Now, this is the other cool thing, and this is where the name distributed comes from. If I want to do a real test, I don't want all 5 million users or 10 million transactions coming from the same region. If I have a global organization, I want all of these coming from different places. So I'm going to say I want this many coming from this region. I want, let's say, another By the way, I'm terrible with math, so I'm just gonna say 10,000, but I have no idea because I'm putting numbers out of my pocket. So I'm gonna get this many from this other region. I'm gonna get another this many for this other region, and so on, right? So you can deploy this solution on any single region that's supported. And what will happen is that the solution in real time, when you want to do a test, and let me actually do it right now. Let me make, because this is my demo environment, so I'm just gonna keep it simple. And I want this to run really fast. Okay. Okay, perfect. I want to say, okay, I'm going to simulate 10 users. You know what? Let's make it fun. Let's say 20, right? And I want these 10,000, whatever, to go from 0 to 10,000. I want to get there in 1 minute. That's ramp up, right? And then once I get to that goal of 10,000, that's what it comes endurance. I want to stay there, let's say, for another 1 minute. Should be more than that, but you get the point. Now, I'm gonna run it now. I'm gonna include live statistics just because I want for you guys to see like the little dots as they happen. But here is another cool thing. I can do a test for a single HTTP endpoint, an API, a website, whatever. Or how many of you familiar with JMeter? Perfect. Let's go and use JMeter. And I'm gonna go reasons. Hopefully it's right here. Okay, conference. Come on. See, that's the problem with a live demo. Okay. This is actually it's not from last year. I just didn't rename the folder. But there you go. Perfect. That's a JMeter script, right? Now, how many of you familiar with Locus or K6? No one? So JMeter is the most like standard, very well-known testing framework. Locus is very similar, but it's for Python developers, and K6, same thing, but for JavaScript developers. So the good news for you that know K6 is that we're going to start supporting K6 and Locus in the upcoming release, hopefully within the next 45 to 60 days. So whether it's JMeter, K6, or Locus you want to use for your performance testing, the solution is going to support that. So perfect. I'm going to say this is the JMeter file I want to use, and I'm going to go ahead and run the test. So this is what's happening right now. In real time, the solution is talking to all the geos, all the regions that I told them to help. And in real time, the solution is going to all the regions telling them, spin up the infrastructure I need for this particular test. So if I click here, you see region 1, 2, and 3. Right now, nothing is happening, but I put a test to run as I was doing this. Let me see if it's happening. So dashboard, perfect, yeah. So you see these other tests. I'm actually running this test right now. Come on, there you go, perfect. So see, this is a test that I set up like 2 hours ago to start as I was starting this demo, right? Because I didn't want for you guys to wait all that time. I know that we're pressing time. But you see here that I'm doing a test with transaction virtual users coming from 3 different regions. Could be 3, could be 5, could be 20, could be 1,000 users, could be 5,000 users, could be 1,000,000 users, right? So on the top left, what you see is the response time in real time. So this is the test going to the endpoint, to the server, to whatever it is, and getting a response, whether it's okay or a success or a failure or whatever. The top right is the virtual users being generated. And here, the different colors, maybe not well appreciated, is that this many are coming from this region, this many virtual users are coming from that region, and so on. On the bottom left, you have successes. At this time, the environment I'm testing against is perfectly fine. Every single one is a success. And if you look at failures, 0 failures. Now, one quick, really good, a piece of news. The solution have to run on AWS. The system you are testing against could be running anywhere. Could be on-prem, could be on any other cloud, could be on your backyard. We don't care. As long as we can get to it, and the solution can get to it, we can do all the simulation. So again, this is the solution running. So I'm gonna skip this. But if I go to the ECS console, come on. Perfect, I have 5 minutes. So if I go to the console and I go to ECS, so I'm in Virginia right now. Let me go to Ohio. If I go clusters, I have this particular cluster. And you see that here, I have a couple of tasks running. If I go to Japan, I have a couple of. Now, why the difference? Because I don't know if you remember, I told that out of Japan, I only needed 2 containers. And if I go to the other one, which I don't know, I think it was like Singapore maybe. We couldn't find it yet. Never mind. Yeah, I didn't deploy in Singapore. But you get the point, right? The solution in real time connects with all the regions, deploys the infrastructure, runs the test, and when the test completes, the solution goes back and say, hey, we're done. Die, disappear. We don't want you anymore. Okay, now let me go back to the solution, and I'm gonna show you a test that's already complete. So I'm gonna look at this Graviton test right now. This is a JMX, JMeter1. So I'm gonna explain the results really quick. So number one is every single API or endpoint that it was tested, you can see one by one what were the results. Then I'm gonna change to here. Total counts. So this particular test was able to generate 2.2 million transactions coming from only 100 users, which is right here. So right here, this tells you one container, 100 users from that container, that was able to generate, what is it right here? 2.2 million, out of which all were successful, no errors, and the rate was 18,000 transactions per second. And then you can look at the percentiles, right? You know what percentiles are in the context of performance testing. And what this means is that 99% or 99.9% of the requests or less took less than 0.2 seconds. Now, 100% or less took 1.22. And if you go at the bottom, you see kind of the average response time. Now, let's say that this was a test with hundreds of APIs. And remember, like I said, here, this is this particular API. This is the other API or page or whatever it is in your flow. You can look at it one by one, or you can look at it as part of the summary. Now, let's say that you want to dive deeper into it. Okay, you go to the logs. And if you are familiar with JMeter, for example, I'm in the wrong region. Let me go back to Ohio. There you go, perfect. You can look at the log files, and let me look at this one. You can go ahead and open it. And again, if you know enough about JMeter and you really want to dive deeper, you can go through the entire log files and understand the results. Now, not officially announced, something that we are considering, something that is part of the roadmap. If you would like to see that in the solution, let me know. Let Peter or anyone from AWS know, and somehow that, they will reach out to us. But introducing Gen AI to actually analyze the results. So you run the test, analyze all the results, especially if you have done that same test multiple times. So now we have a baseline. So the test will be able to give you insights. Hey, you run this test, very complex, 300 APIs, endpoints, whatever, because with JMeter, you can do that. You can do like a very complex test, right? Out of the 300, we found that these two are the bottleneck. And based on the error we got, we think that this is the answer to that. So it's something we're considering. I'm not a product manager, big disclaimer. Anything could change between now and then, but it's something we're considering because especially for customers that are using this at massive scale, right? These log files can get quite big. Okay, so and another one really quick here is that, for example, how many of you know x86 versus Graviton? How many of you know what Graviton is? Perfect. It's ARM architecture, running on AWS. So I'm not gonna go through all the details, but this particular test, that one is called x86 and the other one is Graviton. Look at this. On this particular test, running a Graviton workload, we were able to generate 3 million transactions in the duration of the test, which was only 1 minute. But this same test, if I go back to the x86, $2.9 million transactions, right? Again, very simple test. And I have another demo in this environment that Graviton, we were able to generate like 29 million, and with 86, only like 22 million. So this is a really easy way to prove that running a workload on Graviton is gonna be faster and more efficient, right? So again, with performance testing, you can achieve many, many things, like proving that Graviton is better than x86, or proving that your auto-scaling mechanism is working the way it's supposed to be, or making sure that your customers are gonna get the experience they deserve. So with that, I'm gonna say thank you very much for your time. Go to the solutions library, download or deploy this solution, or explore. Again, there are many other solutions, and 100% you will love. And if you need anything else, just reach out to me. Thank you very much.